Yes. So what is the question? I can't hear you. I can't hear you, Usman. Whoever is asking the question. Okay. 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 See, one thing that we do you want to open any file or what? Or do you want me to explain it? No, these all are not normal. No, the green curve is normal. The green curve is normal. Here, in that case, the green curve is normal and the kurtosis is 0, because it's whatever we compute from here for a normal curve, it will be 3, and 3 minus 3, the kurtosis will be 0 for a normal curve. Yes, exactly. Mean, median, and mode are all same for a perfect symmetrical normal distribution. Mean, mode, and median will be same. However, the blue curve, which one? The green one? No, all are not normal. That's what I'm saying. They are not normal. That's what the picture is showing. All of them are not normal. Only the green one is normal. Only the green one is normal, and the one which is normal in terms of kurtosis, we call it mesokurtic. And for it, the value of this kurtosis is 0. See here, within parentheses, within bracket, it says 0, because whatever you compute from here, it will be 3. 3 minus 3 will give you 0. So yes, so that is normal. Only the green one is normal. However, the blue one and the red one, they are not normal. They are kurtotic. They have their shape, the peak in the middle. The peak in the middle is not similar to the peak of this green curve. See this blue one? It's flat. It's spread out. It's not, the peak is not like this. So this one is not normal. It does not, I should say, it does not exactly follow the normal distribution. It's not exact normal distribution. And then again, the red one, it's again not exactly normal distribution. Now again, there are some tolerance levels for, let's say that if I say that the data set is not exactly normal, but it's close to normal. So should I go ahead and treat it as a normal distribution? Yes, we can. It's not that we are not very strict about being normal, about being exactly symmetrical. So the blue and the red curves are not exactly symmetrical or normal. The mean, median, and mode for the blue curve and for the red curve will be different. Did I answer your question? Hello? What is not? How it is not? What is not? Which one is? Which one do you mean? All three of them, you mean? Well, because see the shape. Okay, without going into mathematics, without going into equation, you see the shape of this green curve is a bell-shaped curve. right? The red and blue are not bell-shaped. Skewness is one thing, kurtosis is another thing. Skewness is to see, even if your data is not skewed, their mean is same. In this case, the mean is same. The data is not skewed. However, the sharpness or the peak of this shape here, we are not getting that peak for the blue and the blue and the red curves. So they are not normal. Though they are not skewed, but they are not the peak is not the peak of the green curve. Is it? Is it like? Did I explain it clearly, or you are still confused about it? I think you are comparing it with this one. Though it looks like all these, the blue and the red and the green, they all look like this. They do. They are symmetrical to this point. However, the peak here, one thing is the symmetry, the other thing is the peak. There are two things that we are looking at. One thing is the symmetry, other thing is the peak. Though they are symmetrical, they are not dragged towards the right, or they are not dragged towards the left. However, still the shape that we have here, the distribution that we have here, the sharpness that we have here is not for the normal curve. The green is a perfectly normal curve. However, red and blue, they are not normal because over here the peak is high, which means in this case, in the case of this red one where the peak is high, it shows that we have some values which are very high values, or sorry, there are some data points which are very high values, and therefore we have this high peak here. So this is the high peak here. See the difference here, this difference here, and this difference here. So these are not exactly normally distributed data. Clear? Okay. You want to refer to this slide? Okay. I have few more figures of the curves. I'll scan them and I'll show them to you in the next class, and it will be like, there are like hundreds and thousands of data sets or the curves that you can refer to, but I'll show you that even if the mean is same, the standard deviation could be different. So it's not necessary that even if they are symmetrical, even if they follow the same shape in terms of symmetry, they are not skewed. However, the peak of the data, the peak of this shape is also very important, okay, for being a data set to be normally distributed. So, any question from today's lecture, something which is not clear to you, something that you want me to discuss in more detail in the next class? Don't have any question? Then I'm assuming that all those concepts that we discussed today are clear to you. Okay. Thank you. Thank you all. Thank you so much. And then I'll discuss our next lecture. I'll be with you next week then. Okay?
Hello. Hello.
Yes.
Hello. Thank you. Okay.
Okay. Thank you all. Thank you.
Okay. Thank you very much. Thank you. Thank you.
Okay. Thanks.
We'll meet next week, inshallah.
Sure. Inshallah.
Okay.
Bye for now.
Bye. Okay. मैं कहती कि जो आप लोगों के वो हैं क्वेश्चन हैं इससे रिलेटेड, क्योंकि क्लास का टाइम अब आपका हमने जो दिया होगा तो खत्म हो गया था, कोशिश करें कि ज़रा जल्दी है। ये भी हो सकता है कि नेक्स्ट टाइम हम इसको 9:30 स्टार्ट करें, आप लोग सेकेंड समझता हमें 15-20 मिनट लग जाते हैं, ताकि 9:30 उसको स्टार्ट हो जाएगा वहाँ से उस टाइम पे तो शुरू हो जाए। लेकिन हमारा जो है हम लोग को आप इसलिए लेकिन आपको वक्त क्या है जो टाइम आप ये बता बहुत सारे वो नया करेंगे तो बजाय कि जिस तरह से बजाय बिना करेंगे भी होगा